Well, a very important vector is the vector first component 1, second component 0, if you want to call it x value 1, y value 0, often represented as I. Now, I could make my I boldface to make it look like a vector, or put a little bar above it or a little vector sign above it, but I won't do that.
And?
Well, and j, the vector j, is the vector 0, 1, and that's a standard unit vector pointing, of course, in the direction of the y-axis, 1 unit long, like this one's in the direction of the x-axis, 1 unit long. And I won't make the I and j bold or use any special, characteristics or anything like that for them.
And? I agree.
Oh, okay, well, good. I'm glad we're all in agreement on that. So now the vector, which we would have called in component form 2, 3, is now 2i plus 3j. Remember, of course, the vector is every directed line segment of the length this that points in the same direction as this, but this is just the representative that has its tail at the origin. So, as an example, let u be the vector 2, 4, and v be the vector negative 4i plus 5j. All right, I'm mixing it up on purpose just so you can see what this is all about. I hope you think that's a good idea.
I agree.
I'm glad you do. So let's see. If a directed line segment representing u has initial point 5, 7, what is its terminal point? Oh my. So remember, this vector is 2 units of x, negative 4 units of y. Sorry, I didn't read that properly, but negative 4 units of y. So that means if it has initial point 5, if we add 2, that means it would be, the terminal point would be 7, and the for the x, and 7 minus 4, 3 for the y. So its terminal point would be the point 7, 3. Okay. Here's a question. What is u plus v? Well, you add the component parts. The x component is 2 of this, the x component is negative 4. So u plus v is negative 2i, and then plus 1j, because we got minus 4j plus 5j. That's plus 1j. So negative 2i plus j, and u minus v would be 2 minus negative 4, so 6i. Negative 4 minus 5, so 6i minus 9j. And what is the length of v? Well, square root of negative 4 squared plus 5 squared is the square root of 16 plus 25, which is the square root of 41. The length of v is the square root of 41. You good with that?
I agree.
I'm glad. Okay, so here's another question. Give a unit vector in the direction of u and a unit vector in the direction of v. Well, since we already found the length of this vector is the square root of 41, then it's pretty easy to do that. It'd be 1 divided by the square root of 41, and then times the vector, what is it, negative 4i plus 5j, so negative 4i plus 5j. And that's it. That's a unit vector in the direction of this one. And to do the same thing with this one, why don't I ask you to try that real quick and see if we agree that you can find a unit vector in the direction of this one. All right? Just pause the video for a second. And now returning from that pause, I hope you have the length is the length is square root of 4 plus 16, so square root of 20, which is 2 square roots of 5. So 1 divided by 2 times the square root of 5 times 2i minus 4j. There we have it. That's a unit vector in the direction of u here's the unit vector in the direction of v, and that's good. Okay. Here's a question now, one more. Suppose the vector is 10 units long.
And
I agree.
Well, okay. And it makes an angle of 120 degrees with a positive x-axis.
And
Well, write it in IJ form. Well, good gracious, here's what we know. It's 10 units long, and it makes an angle of 120 degrees with a positive x-axis. So how do we write it in IJ form? Well, it's actually kind of interesting. You could say, well, unit vector in that direction would be cosine of 120 degrees, but you know what? I'm going to give it 120 degrees is the same as 2 pi over 3, so cosine of 2 pi, divided by 3 is supposed to be, here we go, divided by 3, alright, times I, plus sine of same thing, 2 pi, and then divided by 3 j. Now that's a unit vector pointing, I don't know why I got that bold face there, and I didn't mean to, but I'll take it, I guess. Why wasn't it here, and why is it here? That's weird. I didn't even know the software would do that. So,
I agree.
what do you mean you agree? Okay, all right, I'm glad. But that's a unit vector in the direction of 120 degrees from the positive x-axis. And so when we want to make a vector of length 10, all we do is say, okay, we'll copy this, and we'll say 10 times paste. And there it is. Now, this is the correct answer, but we want to be elegant mathematically, of course, and we have to say, well then what is cosine of 2 pi over 3? And you'd say, well, of course that's negative a half. So what we have is 10 times negative a half is negative 5i. And then we get to the other thing. Well, sine of 2 pi over 3. Well, that you should recognize as square root of 3 over 2. So 10 times square root of 3 over 2 is 5 times the square root of 3. Whoops, sorry. I didn't mean to put that where I did. So let's try this again. Plus 5 times the square root of 3 j. There we have it. Perfect answer right here is the vector that's 10 units long and makes an angle of 120 degrees with a positive x-axis.
I agree.
I'm glad.